Okay, let's collect some examples of periodic chains. How do you make a renewal chain periodic? What periods could you potentially emulate here? And so if you remember this set, this was definition of a period of a state was the greatest common divisor of this set here, which are just the times in which you can return to a state with positive probability. So let's see that if you want to generate a renewal chain of period 2, then you better have every state return to itself in multiples of 2 with a positive probability. And so very clearly you want to tie these two states together, 0 and 1. I can return to state 0 with positive probability in 2 moves for sure. But then to extend this to a less trivial setup, you should be able to return in multiples of 2. And so here's an example. You go from 0 to 3, that's 1 move, 2, 3, 4. And these are creating these cycles that move in multiples of 4. You could see how we can run this example on even state 4. So what I'm going to do here is trace back 4 moves to 0. So I have 1, 2, 3, 4, and then maybe I go up to 5 with step 5, and then I conclude on 6, which is again divisible by 2. So I came back in a multiple of 2. And you could see why this is the case after just thinking through and even come up with a condition that essentially says Qn better be 0 for n even, and I'm eliminating all transitions to states in between here, and when I transition to the odd states, that gives me that circular multiples of 2 kind of cyclic nature that the chain will have. Notice you may not want to take 0 as an even number. It depends on how you define it. In any case, adding a self-transition kills any notion of periodicity. So the quickest way to remove periodicity from a chain is to add a self-transition, and so you have to set Q naught equal to 0 to preclude that. So here's another example. I'm going to try to create a chain of period 3, so I want to be returning in multiples of 3. And so here's the basic example is moving to 2 in one step and then concluding in 2, 3. And what you're trying to again is create these clear cycles, right? These paths that will work, in lengths of that are divisible by 3. And so always you're taking is one step, and then once you kind of get to a number that's right before something that's divisible by 3, you'll then be able to come back in the remaining time units, and that trip will be again divisible by 3. So all I'm doing here is just connecting these cycles, and the lengths of cycles are multiples of 3, and then I can write down the conditions for a period 3 chain, which would be I want to transition to a number that's right before a multiple of 3 with positive probability, but I don't want to have any other transitions because that will break my periodicity condition. So hopefully it shouldn't be too hard to write down just based on these 2 examples how to generate a renewal chain of any period, right? We just made one of period 2, period 3. It's not a far reach to write the condition that generates any periodicity in the renewal chain, so I'll leave that exercise to you.